Question 6. A student investigated the voltage produced by different pairs of metal electrodes in a chemical cell. Figure 6 shows the apparatus used. Figure 6. We got a voltmeter here. We got a plate here which is made up of nickel, another plate, electrode A, and an electrolyte here with a concentration of 1 molar sodium chloride solution. This is the method used. 1. Place a nickel plate electrode and an electrode made from a different metal, electrode A, in 1 molar solution, that is mole per decimeter cube, sodium chloride solution. 2. Measure the voltage produced. Repeat using different metals for electrode A. Table 3 shows the results. Electrode A are copper, magnesium, nickel, silver, zinc. And here are the symbols, and these are the respective voltage. Here I'm showing the metal reactivity here as well. This is an extra information from me. Question 6.1. Write the symbol of the 5 metals in table 3 in order of reactivity. So their order of reactivity, the more positive, the more reactive from the voltage. So this is the more positive, followed by that one, then followed by that, followed by that. That is the least reactivity here. So we're going to write it down in terms of the more positive. So that's magnesium, zinc, nickel, copper, and silver. Justification: the higher the positive voltage, the more reactive the metals. 6.2. The voltage produced by the chemical cells depends on the concentration of the electrolyte solution. Plan an experiment to investigate how the voltage produced by a chemical cell varies with the concentration of the electrolyte solution. The following substances are available. 1. The metal electrode in table 3. 1 molar, which is mole per decimeter cube, sodium chloride solution. Pure water. The first thing we do is to set up with sodium chloride solution as the electrolyte. Then we use 2 different metals as electrodes. We measure the voltage. We need to repeat different concentration of electrolyte solution by diluting the sodium chloride solution with water using measured volume of sodium chloride solution and water. We measure volumes with a measuring cylinder or pipette or burette. Use the same 2 metals each time. We also use the same volume of electrolyte solution. Question 6.3. Describe how a hydrogen fuel cell produces a potential difference. At the anode, the hydrogen gas goes in and loses electrons. So this is the equation for it. Naturally, you write H2 go to H plus E minus. Because it's 2 hydrogens, so you need 2 electrons. But altogether it was 2 hydrogen gas, 2 stoichiometric mole, giving 4 stoichiometric mole of H plus and 4 stoichiometric mole of electrons. So that's the equation for that. This is hydrogen oxidized electrochemically. And then at the cathode, the oxygen, which comes in on the other side, then gain those 4 H pluses and the 4 electrons to then form water. So at the end of it, you get clean water out. For fuel cell, hydrogen fuel cells, you get clean water out. So that is to produce water. And the diagram for it is really, that's the hydrogen going in, losing electron, and the water coming out, the air going in there, the oxygen going in there, gaining those electrons, because the electron will travel through the cable here, current produced, because when electron flow in one direction, current flow in the opposite direction. Or you can put a light bulb there to see it light up. And the electron goes here, and the oxygen gain the electrons. So hydrogen goes in, lose electron. That's what you're seeing here. Hydrogen going in, losing electron. Those electron flows along there, into there. Oxygen then gain those electrons. So that's O2 plus the electrons and the H pluses, which goes in through. And then you get water produced, then coming out of there. Any excess hydrogen will come out there as well. That's the anode and that's the cathode.